Theorem of external division of chords. Example: in a circle, chord AB and chord CD, when extend, then intersect at exterior point E of circle, then prove that AE into EB is equal to CE into ED. How to prove this example? First draw figure. First draw circle. Chord AB and chord CD, when extend, these two chords are intersect at point E. In the solution given, chord AB and chord CD, when extend, then intersect at point E. To prove, we have to prove that AE into EB is equal to CE into ED. AE into EB is equal to CE into ED. Proof. First, draw segment AD and segment BC. We have to draw these two segments. Now, in triangle, we obtained two triangles, triangle ADE and triangle CBE. In triangle ADE and triangle CBE. In these two triangles, angle AED, congruent angle CEB. Reason is common angle. In these two triangles, angle E is common angle. Angle EAD, second, angle EAD, congruent angle ECB, angle EAD, congruent angle ECB. These two angles are congruent. Reason is angles inscribed in same arc. These two angles are inscribed in same arc. Therefore, triangle ADE, similar triangle CBE. Reason is a test of similarity. These two triangles are similar. Therefore, their corresponding sides are in proportion. AD upon BC, AD upon BC is equal to ED upon EB, ED upon EB is equal to AE upon CE. Reason is CSST, corresponding sides of similar triangle. Therefore, now we have to prove that AE into EB is equal to CE into ED. In this ratio of corresponding sides, AD is not asked AD is not asked in the question. BC is also not asked in the question. Therefore, this ratio is neglect. We have to take this ratio, that is ED. ED is asked. EB is also in true to prove. AE is also in to prove. CE is also in to prove. Therefore, ED upon EB is equal to AE upon CE. Therefore, by cross multiplication, AE into EB, AE into EB is equal to CE into ED. CE into ED. CE into ED, hence proved. Please subscribe my channel, also likes my videos.